Got to do a sound check. Is there sound? Looks like there's sound. We got sound? Let's make sure. Yeah. Good. Now I'm going to be pulling up Desmos, and you're more than welcome to play along if you want to. It's up to you. Normally do this on grid paper. When you put a grid up here, you can't read anything as a student, so we're not going to. So I'm going to draw a really, really ugly ellipse. Looks more like a potato. But it is what it is. And let's say there's a center here at, I don't know, 9, 12. I've got a point up here at 9. $14. I've got a point over here back at 312. That's a sideways ellipse, okay? What's interesting is I only want to draw so much of it. I'm only interested in drawing that right there. Not going to see this piece right here. It's hidden. Now, I'm not going to spend 10 minutes going over how to write the equations of this ellipse. Okay, so I'm not going to ask you what you know because I know the answer to that. Nothing. This thing has a long axis on the x-axis. It's 6 units long. That's a, so I put it over 6 squared. X minus 9 squared because it's x minus h squared. Plus y minus 12 squared because k is 12. And the minor axis goes from 12 to 14. It's 2 units long. Now ellipses add up to be 1. We'll play with Desmos to control this thing. Now, what's created the shaded figure here is 2 lines intersecting the ellipse. All right. I'm going to just kind of guesstimate that this thing has a slope of 2. If I had a grid, we'd find it for sure. I don't know. And that would be your sister. We'll say this line right here has a slope of negative 1/3. So I'm going to switch over to Desmos, and I'm going to type that equation in. I'm going to do a lot of the work on Desmos. In fact, your rubric says, I just want to print out the equations you type in Desmos. That's what it says. You want to do work on paper off the side, by all means, go ahead and do it. I'm not going to.
How do we get it to save it?
How do you get it to create save it? You sign up. I've actually signed up. You can actually just click log in and log in with Google. And once you actually log in, the save button comes up. So you can log in with Google, Facebook, email, whatever you want. But you all have Google accounts, so I would just do a login with Google. All right, what was this thing? This was x minus 9 all squared, sitting over a 36, plus y minus 12 squared, sitting over a 4, equal to a 1. It's going to be up over here at 912. There's your ellipse. Now I've got 2 lines that are intersecting this thing. They both share that common center. Center was at 912, right? We just do point slope form. Nothing more. Nothing more than point slope form. Hope you're on Desmos, kids. Y minus 12 equal to one of the lines I said had a slope of 2. X minus 9. The other one, same point. Slope of negative 1/3. X minus 9. That's not too far off from what I had on paper. Now, whenever you're creating partial figures, what you're going to want to do, and you may very well want to do this on a separate piece of paper, you've got a drawing there. You're going to want to find all these little values everywhere things intersect. And you can actually double click on the point and the coordinates will come up and stay on screen. So I'm going to go over to my piece of paper and I'm going to write all those things down. The lines are probably the easiest thing to control with domain and range, and we had that lesson here. But save that for last, because as soon as you start messing with the lines, the points on the screen disappear. And it's a lot easier if you just have those at your disposal instead of having to look at a piece of paper. There are some other things that we'll want to grab. You're going to want to know that far right point at 1512. You want to know that point at the bottom too. We'll actually keep that one up for you. It's at 910. Now here's the tricky part about enclosed or composite figures, getting it to draw only what you want to draw. Usually you're going to have to write the equation for the ellipse twice. You have to break it into multiple pieces. That's the way it usually works. When you've got a line intersecting, a good technique is to just kind of you can either try and get this half drawn or the top half or the bottom half drawn. I'm actually going to try to draw this top half alone. Okay? What I'm going to do is I'm going to restrict the domain on that equation from here to here. And I'm going to restrict the range from this low y value to this high y value. That's going to draw that top half of the ellipse, and only the top half of the ellipse. Then I'm going to have to come in again and put the equation for the ellipse in and get it to draw this little piece right here. That's why I copied all those numbers down. So I'd have some control. I'd know where to control it too. Oh, and as soon as I clicked over there, what happened to my points? Went away. Isn't that annoying? That's why I put them on a piece of paper. So to draw that top half of the ellipse, my x values are trapped between 4.75, I think that's a 7. Yep. 4.757. To get the less than or equal to symbol, you got to open up that keypad. And the far right value was 13.243. No, it was not. The far right value was the right side of the ellipse at 15. Now, the issue is this piece is still here. And there's no way to just throw away this piece, sadly, because I've already got a restriction on X. It's going to draw everything on X from here to there, and that's included. Okay, so the only thing I can really do is I can start throwing away Y values, and I want to keep the Y values that go from here to here. If I tried to keep Y values that go from the bottom to the top, well, that piece would still be there. That's why I'm saying you're going to have to write two equations to get this to happen. So I'm going to keep Y values from 10.586 up to 14. That's the top half of my ellipse. Now all I have to do is draw that bottom piece. And I'll have the enclosed figure I wanted. Some of you guys may not have written down what I had yet, but that was my restrictions. Now, this is also the reason why you copy stuff down on a piece of paper, because you lose stuff once you start doing this. So it'll show back up in just a second. I'm going to retype the equation for the ellipse in, the entire thing. Don't be concerned about the overdraw. All we're going to keep is this little piece that goes from 8.014 to there. That's all we're going to keep. I'm just going to throw away the rest of that purple. That's really easy to do. We might get lucky because of overlap, but if we just restrict X from 8.014 to 13.243, then all it's going to draw is this bottom piece, and there'll actually be some overlap up top. That'll be it. As far as a picture is concerned, it's probably good enough. Boy, she needs to update that in 2020. And no, that's not how it is. Crazy teachers, they need to adapt. You want to be a whale, you can be a whale. Is that everything we wanted as far as the ellipse goes? Yeah, there's some overlap there up top. Is that a big deal? That's really not. How could you get rid of that overlap? If you want to get rid of that overlap, how could you get rid of that overlap? Restrict Y, that's right, Kelly. If you really didn't want that blue overlap up there, you could just throw a restriction in on Y. Let's see, the low Y value on that thing was 10 because I'm looking at the bottom of the ellipse. The high y value was over here, which on my piece of paper is 10.596. There you go. Now all we need to do is throw away some of those line segments. Then we'll have what we're looking for. So line segments are easy to restrict. You just need to restrict domain. That line needs to go from where x is 9 until x is 9.986, and it'll be controlled. And save these for last because, like I said, points start disappearing once you do restrictions. No, that's not right. My restriction on x is not right, is it? I did this the other day. Save the editing of lines for last. This segment was supposed to go from the bottom to the top. So I actually have to look back at my grid, 8.0149. Why is it doing this to me? There we go. And then you just want part of this green line. You want the green line between 9 and that intersection up there, which we wrote down, 4.757. And that, boys and girls, is how you kind of can create new figures from old figures. And that is your lesson for today. I hope you played along. The rubric's loose. Doesn't it say the rubric is loose? You don't want to do it. Nobody says I have to give you 100. God, the rubric is loose. Don't ask me how many you need to have. The rubric is loose. It doesn't say what all you have to have. It's a loose rubric. It says I expect to see partials.
It says 40 equations, so we have to have 40 equations.
Have to have 40 equations. You hit save by hitting save. You can name it too if you want. It also, one thing it says is equations of lines may only be used when you create partial figures. So any equations of lines that you give me are like those. We cut other figures up. And it also says that I'm going to be teaching you some more stuff next 6 weeks, so try to incorporate some things like rotated ellipses or parabolas. Can't do it yet, but I'll show you how to do it later. You're going to keep adding to this one. Apparently I need to read that rubric to y'all. See, first statement, there must be at least 40 equations. You must have lines, circles, parabolas, both left and right, and up and down, ellipses, x-axis and y-axis measure, just one hyperbola. All equations and lines must be equations that break apart or enclose another figure. That's all I want. I don't want simple lines. I want them doing something else. Enjoy your day and your weekend.